So the first thing you're going to want to do is install Python. I installed Python using Anaconda, so my package manager is called Conda, and you'll see what that means in just a second. So I'm going to go ahead and open up my terminal. Cool. So now we're in our terminal, and I'm going to create an environment. So to do that, I'm going to do conda create -- name and an environment called TWH. Okay, and I already have one with that name, so I'm gonna go ahead and replace it. Alright, cool. Okay, and now I'm gonna activate that environment by going conda activate TWH. Sweet. Now I'm gonna of course install Jupyter Lab by going conda install Jupyter Lab. But I'm gonna also install some other libraries like NumPy, Matplotlib, Seaborn, and of course pandas. Yes. Okay. I'm gonna let that install. It's gonna take a second to install. Okay, cool. Alright, so in the meantime, I'll explain to you guys why we use environments is because environments are, it's just good practice. You really don't need to use an environment. You can just run Jupyter Lab and install the packages right into there, but this is a good way to do it if you're working on multiple projects that require different versions of the packages or of the libraries. So let's say I needed to use like a specific version of Matplotlib in one of my projects, like that would have a specific environment to do that. Alright, cool. So now all that has been installed, and I'm gonna go ahead and run Jupyter Lab by going Jupyter space lab. And it's gonna pop up in just a second. Or it should. Yep, there it goes. Cool. Alright, and this is Jupyter Lab. So it's opening a file that I have on my desktop called TWH Workshop, and this is some example code that I wrote that I will show you guys and kind of break down. And after I break this down, we're going to go ahead and try to write our own. So as you can see, it is on Chrome. It opens up in Chrome, or like in Chrome. So that's interesting. That's something interesting about this. And we call these files notebooks. So every time you're going to want to make a new file, it's going to be called a notebook, and you're going to want to select Python for writing Python code. I'm going to just go ahead and close that. Oh, whatever. Okay, so let's look at this code called penguins. So the first thing you're going to want to do is, like in Python, you're going to want to import all the libraries that you're going to need for your project. Yeah, we aren't really going to use NumPy too much in this one, or actually we're not going to use it at all. We're going to mainly use pandas, but we're also using Matplotlib and Seaborn to show and display our data later on. Okay, and so the first thing we're going to want to do is read in our data. So I'm using this data that I found on GitHub. Let me open that link for you guys and show you what it looks like. Okay, and the data looks like this. So as you can see, we got species, island, Coleman length, Coleman depth, flipper length, and all these interesting things about penguins. And we can see like that these are each representative of a penguin of a specific species on whatever island. It's pretty cool. Okay, now let's go back. So what we're going to want to do is store our data into this variable called data. And I'm going to do pandas.read_csv to read that data in. And we can use this function, the head function, to showcase a particular number of elements. If we don't put any number in here, it's going to default show 5, but I just put 7 in. Okay, and to find out how many values we have in the data, in the data set, we can use this len function, which you guys might be familiar with just from using Python. Len data, will give us 344. So that's 344 penguins that are represented in this data frame. Now, what is a data frame? Well, see this this variable data is actually a data frame, and what a data frame is it's basically a table where values are indexed so they can be easily accessed and set. And there's two types of indices in pandas. You can use a label index, which is going to be usually a string that is either a row, the name of a row or a column, and we're going to have a numeric index, which is just like how you access matrices or how you access data in arrays, which is like by the index number. So 0, 0 would give you like that string right there. Okay, and when we work with data frames, we often want to group together different subsets of data. So let's say here I want to show all the sex, just a sec. So I just want to take a look at the sex column. So I'm going to do data subsex dot head. So doing this, I'm basically just showing an array of the sex of the penguins. And here we can see that we have male, female, male, undefined, female, so that's interesting. Okay, and now if you want to know if the penguins are female, so if the sex is female, how we would do that is access that data set the same way by going data subsex, but we set it equal to female, so now that will return an array of Boolean variables for whether or not that sex is actually female. Okay, so now that we have a list that tells us for each row in that column whether or not the penguin is female, we want to get the characteristics of those penguins alone. So we want to see the entire set of attributes for all the female penguins. So to do that, we would go data subsex equals female. So here we are basically saying that we want to see the entire sort of like all of the attributes of data for an index for this index, which is basically if it satisfies this condition that the sex is female, then we're going to show the entire set of data for that. Okay, now suppose we want to add a new column to specify that all of our penguins are penguins. So to add a new column, you'd simply go data sub whatever column you choose to add. Make sure you put quotations because it is a string, and we say that and then we set it equal to penguin, so that makes all of them penguin. And again, we can see that. Okay, so now suppose we want to assign all the penguins a name such that all the girl penguins are named Katara. Based on what we already know, we can split up our code a little. So we know that doing data subsex equals female will give us like all of the data for the female penguins, like I just did up here. So we might be able to do something like this, like going data and then data subsex equals female. So that gives us access to the row. So the rows where the sex is female, and the column would be the name. So we would essentially get all the data, or we would assign all of the names, which is not actually in here yet, but we'll assign name as Katara for all the females. So this actually throws an error, and it just doesn't work. And there is a way to do this that will work, and it is to use this .loc syntax, which clearly specifies rows and columns when you're assigning values. So what you can do is go data.loc row indices and column indices, and then set that to the value. So that's what we're going to do down here, but you can also use numerical indices, and when you use numerical indices, you want to make sure you use iloc. So here I have data subsex equals female. So that's kind of like exactly what I was doing up here, where I was like data, and then this would be like the row index, and this would be like the column index, or the index and the column. Something that I found to be confusing was that in Python they actually call the rows index and the columns columns. Okay, that's a side note. But essentially it's the same thing, but I'm just doing it in this lock format where it's like row, comma, column. So same thing, equals to Katara equals Katara, and I show that, and it works. So that's great. Okay, and now I want to do the same thing to the males, but I'm gonna name them Aang, and that's data.log, data sex equals male, name Aang. Show that, cool. And now we want to see how many of our data is actually, or like data for these two attributes are undefined. So what I'm going to do is len data sub sex dot is na plus len data body mass is na. So here, as you can see, like you can still use this formatting to access, which clearly it worked up here to access, right? But you just can't assign things to it. So here I'm gonna do the same thing, apply the same principle, and just kind of count by accessing that data. And is an A, I had to look that up through the documentation. So yeah, that's 13 when you do the len. Okay, now that's good. There's not too many, so we can kind of just get rid of all of them. So to do that, we're going to do data equals, so kind of redefining data to be the data without any of the NaN undefined values. So we go data.drop NA, axis equals index, how any. So this, if you look at the documentation, basically what this is saying is axis is basically the rows. So we're going to look at the rows and see if the rows have any undefined values. Okay, that's a bad example. Let me look up here. So if the rows have any undefined values, that's why we did any. How is any? You can do any or all. All would be like if all of them were undefined. But see, even in this one, we kind of have penguin. So what we want to do is we want to get rid of all the rows that have any undefined values, so we can just kind of clean up our data and make sure we can present it with all of the attributes that we need. So that's what I did here, and as you can see now, everything should have some sort of data, some sort of number or string for each column. Okay, so now let's do some real work with this data. Okay, so we want to see whether or not there's a relationship between the weights of the penguins and their sex. And we also want to separate the species in order to make sure that our data visualization is appropriately controlled. Now the Seaborn library, which is this Seaborn, the package we installed earlier that I mentioned, it actually builds on the matplotlib library to make data visualization even easier from data frames. And so in the following function call, we'll create a categorical scatter plot with the different species on our x-axis, and their weights on the y-axis, and we can separate their genders using the hue variable, and the hue will kind of differentiate an attribute by color, or like a column by color, and the library will take care of basically everything and make it look really nice. So here we did sns.catplot, data equals data, x equals species, y is body mass, and hue equals sex. And if you look up the documentation for this, it makes it a lot easier. Honestly, I don't remember what all the parameters are for a lot of functions in Python in general. So using documentation is a really good practice. Okay, and when I run that, it looks something like this, which, I mean, this is probably what we expected. The males are heavier than the females, but if you look at the chinstrap penguins, it's kind of less distinct. So let's do some more stats on that and see if there's actually a significant difference between the male and female body masses of chinstrap penguins. I kept saying weight, I meant mass, my bad. All right, so chinstrap. So what we're going to do now is we're going to kind of isolate the data just for the chinstrap. So we're going to make a new data frame. Chinstrap equals data, and then data at species equals chinstrap. So we're going to get all of the rows of data for the penguins that had species that was defined as chinstrap. So then we're gonna make arrays out of that data set. So we're gonna do here, we're basically gonna store all the male weights by doing chinstrap sex equals male body mass. So that will kind of just let us access all the male body masses. And then for female weights, do the same thing. I don't know why I wrote weights. I meant to say mass, but whatever. Chin strap, sex equals female, body mass, same thing. And then from SciPy, import stats. So here, as you can see, we can import whatever package or library at any point. We don't have to do it in the beginning. We can kind of just do it here. That's one of the benefits of using Jupyter Lab is you can run things in isolation, and we'll get more into that when we actually do it, but that's just something to note there. And then I looked up this function called stats.t-test, and then this basically performs a t-test, and as we can see, the results give us that the p-value is really small. It's 2.04 times 10 to the negative 6. That's the test statistic, but we don't need to know about that. And we can see that our p-value is so small, and that indicates that there is a significant difference between the male and female body masses. And that is the end of our demo. Okay, so now we're going to write our own code, and we're going to write our own Jupyter Lab notebook. So let's go ahead and name this file, save it as something. Okay, I'm going to call this TEWH leaf, because I'm going to be using some leaf data. Okay, so actually first thing I'm going to do is import all the packages that I need. So import matplotlib as no.pyplot as plt, import, I don't know why I started with matplotlib, numpy as np, import pandas as pd, and finally import seaborn as sns. Nice. Okay, now to run, so each of these cells we can run on their own, and then we can run the cells in whatever order, but to run a cell we're going to click shift enter, and so that runs it. This should have said 3, but I was messing with this earlier. Should have said 1, but I was messing with it earlier, so that's why it says 3. And it basically just will go in like the order that you ran them. So the next one that I run will be 4, and when you get the number, that's when you know that it has run. Okay, so to add cells, like to add a cell above or below, you're gonna want to click out of it. And if you click A, it adds one above, and if you click B, it adds one below. And to delete cells that you're not using, you can just click DD, DD, and that's how you delete cells. Okay, so now let's add another one by running this guy again. Okay, and I'm gonna go ahead and import some data. So I'm gonna go data equals pd dot read underscore csv, and the data I'm going to be using is called leaf shape. Well, before I do that, I kind of want to look at the data that I'm going to be working with. So this is that right here. So as you can see, we have a bunch of attributes for leaves, random leaves, in different locations. So this is Saba and Panama, Costa Rica, etc. And we can see that there's this empty column here, which is an index column. It's called an index column because we just see that like there's no data in it. It's just a default, like it's a column that the data set already had that just shows us shows us the row number. So that's interesting. And yeah, okay. So what I'm gonna do now is instead of just importing this data, I'm gonna actually assign this to be the index column. So that looks like this. I'm gonna go leaf shape.csv and then index underscore call equals 0. I'm gonna run that. Actually, I kind of want to see what that looks like. So I'm gonna do data.head, and that's what that looks like. As we can see now, the indices are here, but they start at 1 instead of 0 like normal. And that, I don't know, that kind of bothers me, so I'm going to try to fix that. And what I did to fix that is I looked up some documentation. So Pandas has this function called reset index. And essentially what that will do is it will change, or it'll make, sorry, that's not what I wanted to see, but it will make the indices, restart from the top. And to do that, I'm gonna go ahead and so you see this reset index, and then the drop parameter here is just to reset the index without inserting a new column. So usually when you do reset index, it generates like a new index column, but for this one, we're just gonna like restart the numbering, but we're not gonna insert a new one. So we're gonna do index equals call. So I'm gonna go ahead and do data equals data dot reset underscore index, and then I'm gonna do let's look at the documentation again. Okay, yeah, and then I'm just gonna do drop equals false. I'm gonna go data head again just to see what that looks like. Oh, dot head. That is not what I'm, okay, data dot head, there we go. Okay, and then perfect, so that restarts. Okay, now I just want to see how many leaves that we have in this data set, so I'm going to go ahead and just do len data, just to get a good look. Run that, and it's 286, okay. Nice. Alright, so now let's look at our data again and see how we can kind of organize it. Alright, so looking at the data, I see that here we have this thing called arch that's a bunch of zeros and ones. Look weird. So what I did was I went back to where I found this data set. So I found this data set actually in this internet place where I downloaded it. So it was called leaf shape. So I'm gonna actually look here. We're gonna go to this documentation of it and see what the columns actually mean. So these are all, you know, what we expected, but this arch actually is leaf architecture, and 0 is plagiotropic and 1 is orthotropic. Now I don't know what that means actually because I'm not a botanist, but what I'm gonna do is I'm gonna kind of reset this data so that instead of having zeros and ones, we actually have either plagiotropic or orthotropic, depending on whether or not it's a 0 or 1. Alright, now to do that, I'm going to first make sure I reassign all of these integer values to strings. So to do that, I'm going to go data at arc equals data at arc dot apply str. That should turn them all into strings. Then I'm going to go ahead and reassign them by going data dot lock. We'll do data arc equals 0, and if it equals, actually we want to make sure the 0 is a string, equals, and then the column index would be arc, and that's equals plagiotropic. And we'll do the same thing for the other kind. Make sure. And let's look at what that, or see if it actually even compiles. Oh, data.head. Perfect. Okay, so we can see that things have updated. We're not entirely sure if the orthotropic ones have set, but I mean, probably have. And if I look back at this data, I noticed that there are a lot more zeros, so a lot more plagiotropic than orthotropic. So I'm going to make a new column called rare, and it will decide if it's rare or not based on whether or not its architecture is orthotropic or plagiotropic. So I'm going to go data sub rare, and I'm going to set that to a default of false. Then I'm going to go data.loc, and then data at arc equals orthotropic. Yep. And then for my column, I'm going to make it rare, and then I'm going to set that equal to true. Okay, and let's see if that updated. So now let's make a bar chart to show how many of each type, either plagiotropic or orthotropic leaf architecture, a particular location has. To do that, I'm going to go ahead and just make a variable a equals sns. So I'm going to use seaborn sns dot count plot, and then for data, I'm going to use the data variable that we created, and then for the x-axis, we're going to use location, and hue, or the thing that we're distinguishing, would be the architecture. So I'm going to go ahead and do that, and let's run it. Alright, so that's what it looks like. Pretty good, except I see there's kind of an issue here with the x-axis. There's things running into each other, so I can adjust the size. So I'm going to go ahead and adjust the size up here. I'm going to go plt dot figure, and then fig size equals, and then let's do 10.5. So I use documentation to like look this up. So if you guys ever need to learn anything, please don't be afraid to look at the documentation on the Python Pandas documentation, MATLAB, CNS documentation. Alright, so now I'm going to create a basic scatter plot to just kind of show all the data, and I want to basically put the blade length on the x-axis and the blade width on the y-axis to see if there's like any sort of correlation between those two. And I'm also going to show some data about the location and the petiole through some settings, which I'll show you guys right now. So I'm going to go ahead and go sns.scatterplot. Data is data. X is going to be our blade length. Y is going to be blade width. And I'm going to say hue is location. So location is going to be distinguished by color. So different locations will get a different colored point. And I'm going to go size equals petiole. Now for this, what that does is that it's going to make the size of the dot different based on the size of the petiole, and that's just kind of good for visualization. It doesn't really tell us anything numerically, so as you can see, that's kind of the parameters that it used. Like if the petiole was like 60, it'd be a big dot. And so that looks pretty good, but it kind of is covering some of the data, so I'm going to change the size to exactly what I had for this one. So let me just copy and paste. Cool. Yeah, that looks really good. Okay, and now, as you can see, in South Queensland, a lot of the leaves have the same blade length and blade width. You can see there seems to be some sort of positive correlation between blade length and blade width. So I'm going to go ahead and visualize that better with a regression plot. So I'm going to go reg plot data equals data. We'll do x is blade length and y is blade width. And I'm going to run that. That looks pretty good. You can see the positive regression there. And yeah, that's about it. Now that we're done with Jupyter Lab, I'm going to go back to my terminal, just down here, and I'm going to go ahead and click Control C. And then yes, you want to shut down the notebook server. So then it's gone and you're back. Just in your environment, and if you close this, the terminal will end, it will terminate. So that's all you need to do. Thank you guys so much for watching. Hope you have a good